like to turn to Dr. Yong jin of Korea Institute of Machinery and Materials. His presentation is titled Trends in the Development of Hydrogen Storage and Propulsion Technologies for Achieving Carbon Neutrality in Maritime Vessels. Hydrogen is green fuel. We have propulsion as well as fuel cell. I think hydrogen is the most suitable fuel source for net zero, but there are many challenges we have to tackle. But technologies have developed so much so that some of them might be and will become available for application. That is why we'd like to cover this topic as well. Dr. Kim has recently published a technical document on a guide to materials applied to eco-friendly alternative fuels contributing to the shipbuilding industry and is carrying out work to respond to new R&D themes in shipbuilding and marine sector. Thank you, Dr. Kim. Please welcome him with a big hand. Thank you for such a kind introduction. I'm very honored and privileged to be part of this important forum for the maritime industry. The themes covered by the previous three presentations is related to eco-ships, as well as the digitalization in the shipping and shipbuilding industry. Today, I'd like to focus more about hydrogen ships and the green ships. Although I have only 15 minutes to go, let me do my best to be brief and to the point. This is the table of contents and agenda I'd like to talk about. Today, I'd like to talk about hydrogen storage technology, the most promising technology in the hydrogen ship, and hydrogen fuel propulsion technology, as well as research activities for the hydrogen vessel currently done by KIMM. My organization, whenever I talk about eco ship, this is the slide I frequently refer to. As you can see on the screen, the data was as of 2018, but above yellow is 1. And if we do not engage ourselves in any kind of activities for decarbonization, and then if we don't do anything, then you can see there is a huge gap in terms of the carbon emissions after 2050. That is why we have to develop various technologies such as propulsion technologies using alternative fuels in order to meet the carbon reduction target set by the IMO. It is all self-evident that we have to continue this journey. There are various themes for ship technologies, operation, design, and alternative fuels. But our focus is more on decarbonization and carbon reduction technology using a propulsion and a fuel cell or other different alternative fuel technologies. And that's the direction we are pursuing right now. In blue is tank to propeller. This is not something we are considering, but in yellow and in orange, well, to tank ammonia is not covered here. Hydrogen and liquid hydrogen using water electrolysis and green hydrogen should be actively used in order to reduce carbon emission using methanol. You can see from the second from the bottom, compared to existing fossil fuels, you cannot significantly reduce carbon emission. That is why we have to go for green hydrogen. Although it's not all green hydrogen, there are various types of hydrogen and fuel sources. And then these days, the government is focused so much on SMR and ammonia. And this shows the performance of propulsion system. And the ammonia performs better, but hydrogen at the top in terms of transmission and distribution, all processes, throughout all processes, if you can reduce some cost, then this can be competitive as well. Let me skip this slide. I think this is not fully updated. But anyway, there are such a variety of strengths and benefits of hydrogen. But let me take an example of a U.S. project, and there is a so-called hydrogen chain. There are various industries, relevant and related industries and academia and communities to be formed. And on the right side, you can see the operation of cars and operation of vessels, and such chains and value chains or supply chains have been built. So I think as a fast follower, I think we can learn from the case of the United States. Now I'd like to turn to hydrogen storage technology. Gaseous hydrogen and liquid hydrogen still have some challenges. The most urgent challenges, three most urgent challenges we have to tackle is embrittlement, temperature, and pressure. In case of gaseous hydrogen, it's such a high pressure, over 200 bar. And in case of liquid hydrogen, it should be kept at a extremely low temperature, below 200 degrees Celsius, minus 200 degrees Celsius. And on the first column on the right side, if pipes or insulator, if there is any leakage, because of the leakage, then icing will take place, and there will be too much concentration of oxygen. If there is any ignition, then that would lead to a big fire. So this temperature factor should be overcome and successfully addressed in order to facilitate the introduction and adoption of hydrogen. In the middle, you can see in the case of nitrogen and helium, and the helium vaporization is 60 times higher than nitrogen. The same goes true for hydrogen. So a very small molecule could be observed into methane. This is another obstacle we have to tackle. Anyone who is working on hydrogen would talk quite a lot about embrittlement. That means small hydrogen molecules would be observed into metal, and that might lead to some rupture and cracks. And this is also a technical challenge we have to tackle. In hydrogen-fueled vessel, hydrogen carriers, there are various types, and Type C is most promising technology for storage. In the U.S. or France, a membrane-type storage vessel and container is currently under use. However, up to AIP is possible, but I don't think that's feasible for commercialization. As for technology for storing liquid hydrogen, in order to achieve high vacuum system, this is available only for subscale in the small-sized container. In order to make this bigger, that is why we are going for low vacuum and high mid vacuum system, and somewhere in the middle. There are various commercialization cases. If time allows, I would love to go one by one, but to highlight important points, as for Japan, I think that commissioning has already been completed, but that's not in operation yet. That's the status. And up until 2025, they want to go for 4 vessels with 400,000 cubic meters capacity. And as for Korea, KSOB and Hanwha Ocean are working on commercialization of this technology. This is something I already talked about in Norway, France, but they are using membrane-type storage container. And AIG certification has been verification has been completed. As for Europe, including the Netherlands, for commercialization, they have set up the roadmap quite in detail. In the case of the United States, as you can see here on the right side, it's just like the United States, but they have created this hydrogen supply chain. The key here is the supply capacity as of 2027, 100 tons per day, and by 2030, their goal is to supply up to 300 tons of hydrogen per day. And this is a project we are working with Busan University, Busan National University. On axis, it's storage capacity. On y-axis, it's maturity for commercialization. Linde Kawasaki, whether it's land-based or seaborne, they are developing products and they have successfully commercialized some of the products. And as for demonstration, pre-so, I think we have some technical issue here. The microphone doesn't work, so interpretation cannot be provided. I'd like to ask for your understanding. Once microphone system starts to work, interpretation will be provided. But technological maturity is not high enough. I'd like to turn to hydrogen fuel propulsion system that refers to traditional engine and PEM-FC related technology. And there are such a variety of developments on various fronts. By 2020, well, alternative fuel was the area of focus, but with the concept of decarbonization was not incorporated, but from 2020 onward, ammonia, hydrogen, and other alternative fuel were considered for the minimization of carbon emission, and various efforts and policies that have been put forth. In the case of Finland, and Belgium, they are going for, and they have commercialized mixed fuel engines and mixed fuel ships. And as for Korea, KSOE, Korea Power Tucson, and SK Gas has introduced and developed a hydrogen mixed fuel engines. So the R&D effort is being carried out quite actively in Korea as well. In the case of the United States and Norway, and they are also working on hydrogen fueled systems. In the case of Norway, liquid hydrogen is used for the propulsion system. This is the first ever development of such a vessel. It's such a milestone. And in the US and France, membrane type storage facility have been developed. And this is something deserves your attention as well. And on a real-time basis, their location and their status are being monitored. And if you visit the website, especially on the right side, well, that's more well-known because, well, they can generate hydrogen internally. Everything is generated internally. So I think, well, it has been quite well known because, well, it toured and traveled across the world. So far, we looked at the status of the development as well as the technology. Now, I'd like to turn to research activities for hydrogen vessel. At my institute, from 1 to 4, that's a national policy project we have been working on, material evaluation, assessment, and specific companies, storage system development, and the fuel development system. We have provided guidelines and guidances as well as advice. And as for water electrolysis and hydrogen storage system, these are the areas where we are doing our development. I'd like to highlight number 5. This is to create infrastructure, well, establishment of reliability test foundation and evaluation system for machinery sector. There are cases where reliability test infrastructure is not there. So with the government budget of 50 billion Korean won, we are building the system so that we can render a technical support for reliability testing. So we are fully dedicated in this regard. And as part of the project, this is not up to date. And on the left bottom, this is the fuel cell system where you can evaluate. This is the system. We can evaluate a part and component at minus 250 degrees Celsius. And on the right side, this is a whole new technology. And with this, we are developing technical documentation. And the documentation will be shared, and it has been already uploaded to a certain extent on our website. And these are upcoming project initiatives, and with a Korea registry. And we are also developing hydrogen spray and various other types of technology. And as for fuel cell, we are also working on a project. At the bottom, I mentioned that vaporization can take place for hydrogen because it is kept and stored at cryogenic temperature. That is why we are working on this front for the development of general purpose PEM-FC power packs. And our goal is to apply this technology in the field by 2025. This is the end of my presentation. I'd like to ask for your understanding that not the entire document is not up to date, but this will give you a glance of what we are doing. And as for opportunities, challenges, we are working on e-hydrogen, e-ammonia, and e-methanol. And we are also developing piping as well as the propulsion system in taking into consideration the corrosive properties of the marine environment. And we are also working on the economic feasibility test as well. And we will continue to work on our technological development effort. Thank you.
고맙습니다. 열정적이고.
Thank you very much for your passionate and detailed presentation. Please give him another round of big hand. Thank you very much for your presentation. I know we will continue with the panel discussion after we arrange a sitting.
The stage, and the panel discussion will follow right away. Thank you.